so sekarang ni we come to the second video ni. Kita tengok daripada graph pula. Okay, kalau you tengok graph sekarang, okay, okay, ni x equals to 1, x equals to 2, x equals to 3, 4, 5 and 6 kan. So kalau you macam tadi saya tanya dulu, what is the value of fx when x equals to 1? Okay, f1, okay, as x approaching 1, kalau you tengok, bukan x approaching 1, as at x equals to 1, maknanya cari ni as x sama dengan 1 ni, naik, tengok ada tak intersection dengan value of y daripada graph ni. Dekat graph ni, dia cross kat mana? When x equals to 1, you can clearly see is equals to 2, betul? Is equals to 2. F1 is equals to 2. Dan pada masa yang sama, dia punya limit of fx as x approaching 1. Maknanya daripada belah kiri 1 is coming all the way from the left of 1 on the curve ni. Kan, nampak tak? Is pointing to the same value as at x equals to 1. And from the right pula, daripada sini dia menghampiri 1, maknanya dia pointing to the same value as at x equals to 1, which is equals to 2. So that's why lah kita dapat limit of fx as approaching 1 is also equals to 2. Okay, clear Alright, tapi kes ni akan berbeza kalau tengok pula at x equals to 2. Alright, at x equals to 2 kat sini. F2. What is the value when x equals to 2? Okay, by right kita akan tengok. You tengok ni. Will you say that when x equals to 2, our fx ni, y kita ni sama dengan fx ya. Fx kita sama dengan 3. Shall we say is equals to 3? Kalau tengok curve ni, nampak macam betul dan yang 3. Tapi ada nampak tak benda pelik sikit kat sini? Yes, it is pelik sebab at x equals to 1 tadi, dia tak ada apa-apa putih macam ni. Yes, it is a smooth curve. However, here, kita ada lubang putih. Or some of you would say, it's a donut lah, cincin lah, whatsoever. This is actually class to indicate that at x equals to 2, it's not equals to 3, but it's not defined. Okay, it's not equals to 3. At x equals to 2, it is not defined at 3. Okay, dia tak sama dengan 3 sebenarnya sebab dia berlubang dekat 3 tu. At x equals to 2 ni, dia berlubang. Alright. But if you go up further, kalau you pergi tengok, try naik atas, nampak tak ada titik hitam kat sini? Then, yes, this is actually the real value of fx when x equals to 2. Apa value dia? 3 here, 4, ni 5. So, sebenarnya F2 is equals to 5. Okay, sebab dia define. Ya, titik hitam ni maknanya dia define at x equals to 2. Alright? Okay. Seterusnya, soalan tanya, limit fx as x approaching 2. X approaching 2. Can we say... Okay, can we say limit fx as x approaching 2 sama dengan 5 juga? No, you can't say is equal to 5 sebab dia tak ada apa. Dia tiba-tiba je datang satu titik saja. It's not coming from the left or from the right. Okay, it's not coming all the way from the left or right. So, kita tak boleh kata dia ada had. Okay, tapi kita rujuk balik ke dalam curve ni sebab there is a curve defined for x less than 2 and for x more than 2. Nampak tak? Coming all the way from the right of 2, maknanya from the right, kita guna tambah. From the left, kita guna tolak. 2, tolak ni maknanya dia coming from the left of 2 and from the right of 2. And it is pointing to the same value. Di curve ni daripada arah kanan menghampiri 2 dan daripada arah kiri menghampiri 2, dia menghampiri kepada satu common value which is equals to 3. Okay, hopefully semua orang faham lah. So, limit fx as x approaching 2 is not equals to 5 but is equals to 3. Ni lah jawapan dia. Yang ni is equals to 3. Okay. Okay. So, kita dah discuss yang ni. And the same goes for this example. Nampak tak? Limit fx as x approaching 3. Ni 3 kita. So, as x approaching 3 daripada kiri. Ni curve. Dia ada, bila dah ada curve, baru kita boleh kata dia ada jalan. Okay, kalau macam ni, macam ni dia terbang. No way. There is no way that dia terbang. Dia kena ada jalan baru dia boleh menghampiri titik ni. Okay, bila ada jalan maknanya dia kena ada curve baru dia ada jalan untuk dia menghampiri titik ni walaupun dia berlubang kat sini. Because at x equals to 3, f3 it's not equals to 4 sebab dia berlubang. Tapi limit fx as x approaching 3, yes, it is equals to 4 sebab dia hanya menghampiri 3 tapi dia tak sama dengan 3. Okay, at x equals to 3, no, it's not equals to 4. Tapi limit fx as x approaching 3 from the left and from the right is pointing to the same value which is 4. Okay, so hope all of you clear about this graphically. Dia lagi senang faham bila tengok graph macam ni lah. Okay, so settle with that. Now, kita proceed to this. Okay, basically yang ni apa yang saya nak cakap kat sini ni sebenarnya we have indirectly discussed. Okay, one-sided limit. Kan saya dah kata all the way from the left, all the way from the right. So that is so-called as one-sided limit. Limit fx, kalau x tu datang daripada arah kanan, kita denote dia with a plus macam ni. X approaching a from the right is equals to one particular value. And from the left is equals to one particular value L. L can be any number. A pun tak semestinya A. Maknanya A can be any number lah. Negatif 1, 0, 1, 2, 3 and so on. Alright. Panjang ayat dia ni tak apa. Tak payah baca pun tak apa. As long as awak faham je. Okay, let's have a look at example 3 kat sini. Nampak tak? This graph kan. Kita ada dua line kat sini. Line biru ni is our curve. Okay. Ni dia punya jalan. Okay. So kat sini limit fx as x approaching 0 from the left. Daripada kiri kosong. Daripada kiri kosong dia menghampiri value apa? Dia menghampiri negatif 1. Betul? And daripada kanan kosong, dia menghampiri kosong, value of fx is equals to 1. Betul? So sekarang ni, limit fx as x approaching 0 from the left is negative 1. Limit fx as x approaching 0 from the right is equals to 1. So, mana satu kita nak kata ni? Which one shall we say? What can we conclude? Limit fx as x approaching 0. Nak guna 1 ke nak guna negatif 1? As x approaching 0. Maknanya dekat x sama dengan kosong tu, as x approaching 0, okay, kosong, bukan daripada kiri dan kanan. What is the value of the limit? No, we can't conclude. Sebabnya dari arah kiri, dia dari arah kiri dia sama negatif 1. Dari arah kanan dia sama dengan 1. So dia tak sama. Okay, limit fx as x approaching 0 does not exist. Because short form ni because limit x approaching 0 from the left of fx is not the same as limit of x approaching 0 from the right. Limit of fx as x approaching 0 from the right. Dia tak sama, so we can't conclude that the limit of fx equals to as limit of fx as x approaching 0 is equals to 1 or negative 1, but we say that the limit does not exist sebab dia ada konflik kat sini. Satu kata negatif 1, satu lagi kata 1. So dia tak sama, dia tak mencapai titik persetujuan. So to be fair to both, we say that the limit at x as x approaching 0 does not exist. Okay? Alright. Okay, one last question before I move to this slide. What is f0? Okay, maknanya what is fx when x equals to 0? Can we say it's equals to 1? Boleh tak sama dengan 1? Tak boleh sebab dia berlubang kat sini. Dia bukan titik hitam. So, no. Can we say it's negative 1? Also no because dia berlubang, donut, cincin, whatsoever. It's not equals to negative 1. So, tak ada titik hitam pun at sepanjang y-axis ni. At x equals to 0. So, we conclude F0 does not exist. F0 does not exist. Okay. Okay, kalau example ni tak ada masalah. Nampak tak? Kalau yang ni, yes, we can say limit fx as x approaching to equals to 3. Kenapa? Sebab kalau you tengok kat sini, limit fx as x approaching to from the right, daripada arah kanan 3 is pointing to 3. Daripada arah kiri, as x approaching 2 from the left also is pointing to 3. Dia common. So, yes, limit fx as x approaching 2 is equals to 3 sebab because yang ni, because limit fx as x approaching 2 from the left sama dengan limit fx as x approaching 2 from the right, which is equals to 3. So, sama, kita carry dan jawapan limit fx as x approaching 2 is also equals to 3. Okay. Alright, clear about this? So, now we come to the conclusion. Okay, limit as x approaching a ni, kita boleh kata sama dengan L sekiranya if and only if limit from the left pun sama dengan L, limit from the right pun sama dengan L. Ataupun you may say limit fx as x approaching a from the left sama dengan limit fx as x approaching a from the right, which is equals to L. Dan dari situ you boleh katalah limit fx as x approaching a is equals to L. Okay. Alright, next. Let's have a look at these two examples. Okay, does limit z for this function at x equals to 2? Mana x equals to 2? Tengok, ni x equals to 2 kan? So, to check this, okay, we have to check limit. Soalan nak cari limit as fx as approaching 2. So, you have to check first limit fx as x approaching 2 from the right. From the right, yang mana satu dari arah kanan. Ni arah kanan kan. So, arah kanan is pointing to, apa value kat sini? 1. Is equals to 1. Then, check pula limit fx as x approaching to from the left. Daripada arah kiri, see, dia arah kiri kita. Value dia sekarang ni, curve dia, jalan dia daripada sini. So, it's pointing to, as x approaching to from the left kat sini, is pointing to 4. So, what shall we conclude? Sama tak limit from the left and limit from the right? No, so this one does not exist. Sebab, ni dengan ni tak sama. Okay, limit from the left and limit from the right tak sama. Tapi, nak test you all. F2 sama dengan berapa? When x equals to 2. Kita nak ambil point ni ke nak ambil point ni? Okay, kita ambil point yang ada tanda hitam ni. Tanda hitam ni, meaning that F2 is equals to 1. Hitam maknanya it's defined. Putih is undefined. Okay, alright, clear about that. Now, let's have a look at B. Okay, for B, we have at x equals to 4. Mana 4? 4 ni jalan dia semua. Dia tak ada lubang apa. Then, no problem. Straight away. From the left and from the right, you can see clearly it's pointing to the same value which is equals to 1. So, meaning that this one, limit fx as x approaching 4 is equals to 1. And in fact, when x equals to 1, f1 is equals to, F4 is equals to also 1. Ni. Titik hitam ni kan. Maknanya dia berada dalam, titik hitam pun tu berada dalam garisan hitam ni. So, F4 is equals to 1. Alright. Then we move to next example here. 1. Okay. Example 7, question number 1. So, let's have A here. Limit of gx as x approaching 5. Mana 5? This is 5. Okay, dia 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, as x approaching 5. Okay, limit of gx as x approaching 5. Kalau you tengok, okay, the graph ni mana jalan dia? From the left and from the right. Yes, it pointing to the same value which is equals to 0. Okay, and B pula as x approaching 9. What about 9 class? Limit fx x approaching 9. Kita tengok dulu because nampak ni dia ada dua jalan ni. From the left dululah. From the left, dari belah kiri, is pointing to what value here? Is pointing to 1. Betul? Okay, and from the right, limit fx as x approaching 9 from the right. Mana jalan daripada arah kanan? Daripada arah kanan ni jalan dia. So it's pointing to apa? It's pointing to 2. So what shall we conclude for this then? Okay, limit gx as x approaching 9. This one does not exist. Yang ni sama dengan kosong. Kenapa does not exist? You have to justify kalau dalam soalan ya. Because limit from the left and limit from the right tak sama. So, limit as x approaching 9 does not exist. Okay. And last question, limit gx as x approaching 4. Ni x approaching 4. Ni 4. Sekarang ni ada titik hitam dekat 4 ni. Apa maksud ni? And dekat 4 ni juga kita ada curve as x approaching 4. So, which one shall we use? Okay, so of course kita kena ada jalan baru kita limit, right? As I said before. So jalan dia adalah yang ni. So as x approaching 4 from the left and 4 from the right is pointing to the same value here, which is 4. So sama je lah. It's equals to 4. Habis tu ni apa? Ni adalah value of fx when x equals to 4. F4 is equals to apa? Is equals to 0. F4 is equals to 0. Alright, so that's all for this part. Okay, this video. For sebenarnya this is a siaran ulangan from our Google Meet class yang mana dia punya recorded video hilang tanpa dikesan, pergi tak kembali, tak tahu macam kenapa. Hopefully it won't happen again in the future lah. Menangis saya nak record the same thing twice. Alright, so that's all for today class. Okay, hopefully it will benefit for all of you to do the revision. Kepada siapa yang dah attend my class last Thursday, and for those who have missed my class on Thursday, please I hope you have watched until up to here lah before we proceed to our asynchronous class on Monday. Okay, that's all. Thank you everyone. Bye bye. Assalamualaikum warahmatullahi taala wabarakatuh.